1, 2, 3, check. Testing audio, testing video. 1, 2, 3, check, check. Okay, I know this is going to work, but let me change back to the earpiece so we have cleaner audio. 1, 2, 3. Okay, there we are. Apologies there. Now we're live and we're having some technical difficulties here. Okay, I want to welcome you all to this the workshop for creating AI agents with ElizaOS and Midnight SDK. This is going to be a bit similar to what we had on the workshop number 1, but we're going to focus more into ElizaOS and how we can interact with it. So yeah, let's go over what we have for the objectives of today's workshop, right? Okay, so we're going to clone the repository for Midnight MCP. That is a very straightforward process, and it has never failed us in the execution, right? So we are having the expectation that everybody watching the workshop can run the process and have a working Midnight wallet exposed via MCP. That's number 1. And number 2, the second objective we have for today is we are going to be going a bit deeper into how we can interact with the ElizaOS via the API, right? Because we're making a lot of stuff programmatically, and not always we have the opportunity to go into the UI and run processes manually, right? So we're going to be checking how we interact with it via the API. That is the second objective for today. Okay, and we're going to have a bit of a project summary. We're going to expedite it since this is reiterative of what we had on the first workshop. Then we're going to run the setup. We're going to demo, and then we're going to go back a bit into the code again, because at that point, after the demo, we're going to figure out how we can give instructions to Eliza and how to communicate with it programmatically, right? Which would not include like manually going to the application and creating the agent and then starting the agent, right? We're doing that manually here, but it can be done programmatically, and we have it already working as part of the end-to-end tasks. So that is what we're going to deep dive into. And from there, we're going to have a session of Q&A in case we have questions. So I want to remind you that we have the workshop file. The workshop file is public, and right there you have all the requirements, and we have the steps that we need to follow. So every time that I reference that we have the step or we have the requirement, we have the command, it's because you have access to the workshop file, which you can follow along, or you can try to follow after the workshop in case you want to pay attention and then try to replicate it later. That's totally fine. So let's get started. Okay, project overview. First, we have developed what is called the Midnight MCP. So, how does this module allow us to expose utilities for the AI agents, right? Okay, we're using the MCP, which stands for Model Context Protocol. It's a standard that has been growing, and we're using particularly their own module, right, which is called Model Context Protocol. And this allows us to expose logic to the AI agents and explain them what is each tool or function used for, right, as well as the requirements. So we have this module. We created all the Midnight Wallet logic, which is to create a wallet, be able to synchronize it, be able to save a local state, so we can have faster startups without having to call start every single time we're going to run the wallet, right? In case you stop the process and you have to reopen it, you don't have to wait for the entire syncing process, but we have stored the backup locally, and then you can resume synchronization from that point. Okay, And we have, as I said, the we have described the wallet, we have described the local state, and we have implementation for smart contracts. Also, we have a couple examples. This is very important to mention that smart contracts are, of course, a custom implementation. So if you design your own contract, you will have to get your hands into the integration of that contract, right? Aside from shielded tokens, because shielded tokens are native to the blockchain, right? We can use them without that many configuration. We have a simple step to add a new token that you might have created via a contract, but in order to use it, you just need a simple variable that is going to include the shielded token if it is one of the UTXO base, right? Okay, so that is the Midnight MCP module. And then we're going to go to step number 2, which is we're going to clone an ElizaOS repository, which allow us to boot the ElizaOS framework, so we can start creating agents and adding configurations so those agents can communicate with the module number 1, the Midnight MCP. Okay, and then finally we're going to use as a client, we're going to be interacting via Discord. So the way that I'm going to be chatting with the agent is going to be from Discord. I will send messages. Discord is being captured by a bot inside of ElizaOS as part of their own offering. So it's very simple to make a Discord bot with the Eliza OS offering, right? It's very simple. And from there, Eliza is making all the reasoning and using the tools that we have provided in order to provide a response or execute an action. Okay, so let's get hands-on to what we have here. This is the workshop file. And I have to go through a couple of the requirements first because this is very sensitive to the versioning. In fact, yesterday we had a demo and a minor change in a version caused some issues. We were able to resolve it, and a new update has been pushed to the Eliza-based agent, so we can avoid that issue happening again. Okay, requirements. We're working with Node.js 22.15.1, so we're going to be confirming everything here. We have Node 22.15.1. We're going to be working with Eliza 1.5.9. ElizaOS V, and there we have 1.5.9. That's correct. Okay, we require Docker. Docker is not a requirement for our modules in this case, but we are using Midnight, and in the end, to make transactions on Midnight, we need to have the proof server, and the proof server is running on Docker. So I have here Docker Desktop. You might be using any kind of Docker implementation. It doesn't matter if it is purely CLI. The important thing here is that we're using Midnight Network, and we're using the following requirement: Midnight Proof Server version 4.0.0. Okay, so that one is already booted. From there, we are going to use Yarn. In our case, we're using Yarn 4.1.0 and Bond. See what version we have here. The same Bond 1.1.20. Okay, so as I said, the first step is going to be cloning this repository, the wallet, and the tooling exposed for AI agent. And down here we have around step 10. We already have the MCP working, and then we do the Eliza agent. So let's go through the Midnight MCP first. Okay, I am here in a directory, and as you can see, I have multiple Midnight MCPs doesn't matter. I'm always creating a new one in order for us to work from a clean state and be able to execute all the steps and see it working without any previous configuration. So we have here, let's call it Midnight MCP EL. I'm going to name it for this one from Eliza, since we're going deeper into Eliza this time. Okay, then we're going to cd into the directory, right? And for now, we're still working on the workshop branch. Okay, this is the one that has the shielded token implementation. It's still pending to go through the rest of the branches. Okay, from the workshop branch, I want to state something. The repository is entirely public, and you can fork it or you can use our implementation. And yeah, feel free to use it. Feel free to make your own, or just keep pulling our updates and using it as it is right now. One sec, I'm catching up with the chat. Okay, we have a good question here, ElizaOS. Okay. So yeah, I see a question about ElizaOS. So we can dive deeper, but we already have some interaction with the chat, providing basic explanation. But yeah, let's take 1 minute before configuring the client here. So ElizaOS is the framework that allows us to create multiple agents, right? So we are going to clone a repository created with their um, framework. ElizaOS allows you to create a project. Then you go into the project and you can start the system, and then that allows us to go into the browser locally, and we can start creating agents that can be used locally via the presented chat. If it is published on a server, then of course that can be public, and anyone could go to your domain and get access to the agents. Or even with the plugins, you can set it up on your host. You can set it up on a server, and then have people interact with it via a Discord bot. And I mean, you can do many things. I have here a list. You can do Discord, Twitter, Telegram interactions. Um, so yeah, even WhatsApp, right? So you can interact with this with multiple ways, and you can provide the agents with multiple integrations, right? Not only communicative like the ones I mentioned, but for example, as we are doing here, we're providing the agent with blockchain capabilities. You can provide it with browser reading, browser scraping, and many other things, right? So yeah, Eliza is this powerful framework that allows us to, with a couple commands, have an AI agent up and running, and having a lot of integrations available out of the box, like the one we're going to see here, which is Discord. Okay, so going back to the setup, so we can go faster on the MCP, and then we can take more time on the Eliza section. Okay, following the commands, let's do yarn install. It has to be done in the clone repository. Okay, then we're going to do yarn build, and that is the project already installed and built. Okay, then we're going to create an agent. In this step, you can see I have one commented. This is the one that I'm using because I'm reusing the seed. The seed is the master key or the private key for our wallet. So yeah, you have access to my wallet in this case. This is extremely important for me to say. I'm doing demos and I'm trying to be as transparent as possible. But this is sensitive information and should not be shared anywhere, right? So you're going to execute the command that is there, right? You can change the A stands for agent ID, so you can use whatever name you want to use, right? We're setting up an agent called workshop. This agent is set up to run locally. That means it's going to run from yarn dev. But for production processes, you would do yarn setup docker, and you're going to follow up with the agent name. That's going to do a slightly different version of the command, and that will allow you to run it from Docker, not run it from terminal. We're doing it this way because we want you to be able to run it local and to make your own integrations into the MCP, because we have something that we're going to be talking later in the workshop, which is the hackathon, right? Okay, so let me run the command here. I'm going to run the setup agent workshop, and we get a couple validations here that, yeah, it is creating some um, utilities in the storage directory, which is a, a data directory. We're storing there the seed for our local wallets. We're storing there the backups, so we can we don't have to call the store every single time we want to make think of the wallet. We have the logs and we have the transactions stored locally. Okay, this is going to give us the seed. Uh, I think I run the pure command. I'm going to run it again because I run the the basic one, and I already have funds in this wallet. So let me make that change here. So let me clear here. Let me remove the storage folder because I don't want to have that information there. And I'm going to run my command, which already have a wallet. And of course, you can use even this wallet if you wanted to. Just avoid using it right now because I'm working with it. Okay, and here we have very sensitive information. This is the seed for Midnight, and we have the mnemonic. We're providing the mnemonic in case you want to connect via the Lace wallet, so you can do it visually on your browser extension, and at the same time you can interact with it, on terminal with the hex. So these two has to be stored and have a good backup of them, right? The second piece of information that we receive is this configuration for the Eliza character, which we're going to talk about in the second phase of the setup. But I'm going to save the result. Okay, so I have here my code editor, and yeah, I'm going to leave that there. Okay, what do we have now? We have the specific mention that the seed is something very sensitive, and we have to copy the configuration. There are a couple examples there just for reference, and we keep moving forward. So we're going to copy the envs, right? And then we are going to edit the env. What are the key points to edit here? Number one is the agent ID. We name it workshop. What happens if you don't make the correction or the update there? You're going to get an error because your agent will not be found in the storage section of the directory. Okay, aside from that, let's add the token that we're using. This is a shielded token. We're adding it for testing. So this is formed by the name that I'm giving it locally, the symbol that I'm giving locally, the deployment contract. So this is the address of the contract that deployed this token. And we have the domain. Domain is like the name of the contract of the token, right? So these two values are really important, the contract address and the domain. Those are mandatory to be exactly the same that were created on the contract. Funding, the name, and the symbol, these are for local reference only, and they are not checked anywhere else, nor used really in the blockchain. This is for local communications only, as well as the description, right? This is locally. Same with the decimal. This last value here is the decimals. So we're adding one decimal, which means this is similar to Satoshi and Bitcoin, right? One Bitcoin is 1 by 10 to the power of 8, right? So similar here in order for us to be able to use decimals. Okay, let's keep going. From there, I just need to do yarn dev, and this is going to start to initiate the server and sync the wallet. So we can see the process is starting. It does recognize the token because once we add the ENV, then it's going to add it to the local database in order to keep track of it. And then it starts to make a sync with the blockchain. We can see it start from very far, and then it starts syncing in batch, and it is periodically storing the backup of the wallet in case you interrupt the process. Then you don't have to do it all over again. So this does take time. So let's keep going in the meantime. Okay, now going into ElizaOS. This is our main topic for today. So we have to install Eliza CLI on our machine. There we have the command, and from there we're going to clone this Eliza base agent. Eliza CLI allows us to create projects. We use their create project function to create this project that we have here. Right? So we are doing this to make it easier and faster for our demo right now. So I'm going to run this command here, but I'm going to change the name of the clone. This is because I do have many copies of each project. So let's call it Eliza base agent focus. Okay, so there we go into the repository. Just to confirm, we had an issue and we applied a fix. I added a comment there that if you have this commit, then you're ahead of the issue we found in our local configuration. Okay, now we need to run install. So we're going to run it with the bun and using the log file. So let's make sure there we have the log file, right? So we're going to run install with frozen dependencies. One sec, I'm going to catch up with the chat. Okay, I'm happy to see that you're having communications in the chat going back and forward. Thank you very much to everyone that is participating. Okay, so we have an issue here with the log file. Let me do install without it. And just to confirm what our issue was with the OpenAI plugin. But yeah, we have the correct version, so we should not face any issues. And I'm going to be committing the changes in case we want to keep the frozen log file. Okay, from here we're going to copy the envs from base into env. Let me open this in the editor. And I will be sharing now because I don't have my private API key here yet. So we can go over the configuration, and later I will, of course, hide it because I need to add my OpenAI key. Okay, so I'm going to do pwd on the Eliza repository directory in my local machine. So then we can add that to this env here, which is the pg lite directory. So I'm going to replace home path to dir, right? And we are going to keep the .eliza and the .eliza db. We'll leave the rest as is, and you need to update your OpenAI key, which I will be doing off screen. So one sec here. And okay, and I have an extra comment there to add also. So I will be adding the key, and then I will let you know the rest that was also included in the env because we have some other values being added. Mhm. Okay, I'm back with the screen. Okay, so we updated our directory for the PG data there, and we also added this couple variables for Discord. So if we go into the example env, the example is the one provided by Eliza. It does have many more values than the one we have on base. Base is a minimum requirement that we have. So I'm adding here the Discord application ID and the Discord API token. In order for us to use the Discord client, you simply have to go through Discord register and create an app. That is, of course, a process that we're not going to be covering here, but it's very simple. You go there, you sign up for the developer uh, permissions, and then you can create an application. And then you get the application ID and you request an API token. You just have to paste them here. And this is why we're talking about Eliza today, right? Adding Discord client is as simple as having these two envs here. Having these two envs allows the framework to be able to communicate uh, with Discord. And of course, a bit of a configuration here in the character. We have the plugin defined in the plugin section. If you don't define it, of course, it will not try to use it. So yeah, you have to include the plugin Discord into the character example. All right, so summary, we added the Discord configuration and we updated the PG Lite directory and we added our real and production ready API key for OpenAI. As I mentioned, you can use multiple um, language models, not only OpenAI, right? Okay, let's keep going. Okay, once we have everything configured, let's take a quick look at the wallet. The wallet seems to be syncing and at the same time getting more blocks, so getting out of sync. That's fine. And we're going to initiate the Eliza OS. I like to initiate it here in terminal. Just I prefer the look of it because we are going to be reading some values here from Eliza. It's not necessary, but I like to do it here. So once I have installed and added the envs, we just run Eliza start. Okay, and, from there, Eliza is going to do some like initialization, connecting, verifying plugins that it needs to download and install, and yeah. Okay, this is a no breaking error, right? This is because it's trying to communicate with the local LLM, which we don't have. But that's not an issue. We're not using that one. We're using OpenAI. Okay, once we have Eliza running, we can go through our browser into the local host. In this case, this is starting the service at port 3001. That is because my wallet is already running on port 3000. So this one is trying to use the following sequence. And yeah, we can see we already have Eliza. We can chat with it or anything, but I'm going to be creating our own agent. So I'm turning off Eliza, and I'm going to explain to you now the character file. Okay, character file, you have one in our example here for the base for the Eliza base agent, and you basically define the name, the biography, like the background of the agent, and as well as you can provide examples of how you want it to do messaging. This helps a lot with the with stuff like giving examples. So it uses a similar tone, a similar way to interact as the one you define here. Same with the post. You can provide an example of how to form or composite a post for that case social media, right? And yeah, we have many configurations that are relevant for the core, the personality, the character of the agent. But um, our relevant section here is the MCP. Inside of settings, we have MCP, which is using the MCP plugin, and inside of it, we have servers. So you can connect it to many MCPs, but right now we're connecting it to Midnight MCP, which is the one we developed. So we have to make these changes here. Where do we get this configuration? This is coming from the module of the Midnight MCP. If you recall, we copied this value here, the output of the generation of the agent. So if we go back to the configuration, we can copy it, all the MCP section. In case you already have another MCPs, of course you will be copying only the Midnight MCP. Right, let's do that. Okay, so there we have it, and we can see we have changes. In my case, only on the path for the location of the project, right? And this is a notable mention. In my case, I'm using NVN, and that is why we have the command as it is right now. You could have a pure node command in case you don't have NVM, right? But this is the way we're doing it. And we have to include the agent ID as part of the command. And this is the name that we use when creating the agent in the step of the configuration. All right, so once we have this, I'm going to be creating an agent here. And I'm doing this visually because that way we know what we're working with. It's easier for us to know. But later we're going down into decoding how these exact steps, we're going to replicate them via CLI. That is the way that is being done in the end-to-end test. Okay, so I'm importing my character, and as soon as I import and I click on save, I have it here. In one important mention for our use case is we're turning off Eliza, right? And I'm turning on C3PO, and I will explain that in a bit. That has to do with Discord. Okay, so I have it turned on now, and just to confirm, we can see here this is the log of the Eliza uh, service, and we can see once we started C3PO, it did some stuff here. Here we have when we turn off Eliza, and here we have C3PO. So it's starting looking if he already has all the dependencies, and at the end it reads the tools that the Midnight MCP is providing to C3PO. So we can see we have wallet status, address, balance, send function, and we have some others for the DAO. We have some others for the uh, marketplace and some other stuff, right? So here we're looking at what we expose to the agent. Technically, you can expose whatever you want. In our case, it's focused on blockchain, but this would be the equivalent of you making, I don't know, a service for whatever offerings you have. And MCP allow us to expose that to Eliza, and Eliza can read it, understand what is the name, what is the description for it, and even the requirements. It does provide the inputs that the NCP needs in order to execute the process. So all of that is defining with the NCP, and so Eliza can understand how to interact with it. Okay, so now we have everything running, and we can even see our Midnight agent is online here. Okay, and why did I say that we needed to turn off Eliza at the time that we turn on C3PO? If I go back here into the history, because we have been doing many demos. Okay, in here, for example, we use a DAO function, right? And we have multiple responses. And this is because we had multiple agents running at the same time. So the communication for Discord is not directly piped um, into C3PO, is piped into the entirety of the ElizaOS. So we have response from Eliza, Eliza saying something that she doesn't know what a DAO is and whatever, so she doesn't have the functionality. And C3PO is replying the correct information. Okay, hold on, I'm going to perform the task that you want. Okay, so this happened because I'm sending it via the entire messaging system. So for our demo, we're turning off Eliza, and we're keeping only C3PO so we get the proper responses. Let's give it a try. Let's do, please check the wallet status. And there we can see that is informing us. It will check the wallet status now. And at this time, it is communicating back and forward with the MCP and also with OpenAI, right? So what we can see is we chat via Discord. Discord was piped to ElizaOS. ElizaOS decides what to do. Okay, I have this message, and I have these tools, and I have everything, right? So it creates like a request. It goes to OpenAI. So OpenAI is actually doing the decision making, but it returns the information to Eliza, and Eliza then knows, okay, I have these tools. I have to call the wallet status function, right? So if we go back, we can see the interactions in terminal, and we can see we have here wallet status. So Eliza and OpenAI define decided that they need to use this function. They use it. They call the wallet status. Here it is, wallet status. So they have reason that okay, I need to use this function in order to get the user information. They did call the function. It went through the Midnight MCP. It came back with the information. Here is the response. Okay. From the Midnight MCP, the Eliza OS received this. The agent received this block of information, and then it is using once again formatting and everything to return it to Discord. So we reply, the wallet is ready, fully synced, not syncing issues, your balance is this much TDOS, and there is no pending transaction, the wallet address is this. So we can see the entire process taking place. Now let's request a token transfer. So we are going to request a token transfer to, let's see if I have it here, an example address. Here it is. Okay, so I will come here and let me reiterate, we need the proof server for this step that I'm about to do, right? The one that we already did doesn't need all of the setting up and everything, doesn't need the proof server because you're reading information. But at the time that you want to start making transactions, you need to have the proof server running and accessible. So I'm going to ask, okay, what is my default balance? We're going to check the balance, then we're going to make the transaction and check the balance after the transaction. Okay, something important here also. Notice that you don't need to tag specifically the agent. If the agent is in the chat, in this case in the channel, then it's going to read all messages and try to reply. You might have different configurations. In case you want it to be like less intrusive, you can use commands at that point, so it only replies if you have a specific commands or inputs. But I set it up so we can chat because it's only the two of us. Okay, so we check the balance is 86 defund. Okay, so let's send, I don't know, 14 defund to this address, and we can provide the address. Okay, we received the first confirmation that is going to send the funds now, and we can come here to the proof server to see something interesting. We had all requests here from a couple days ago, but we can see this transaction being proven right now on the proof server. So a couple seconds ago, like minutes ago, this one here, it started to prove the transaction and it returned the proved transaction. And there we have the response. Oops, here. Okay, I have successfully sent 14 defund to the address, and the transaction ID reference is this one. So there we have it, a live transaction on the Midnight blockchain. Now let's do the wallet checking, the balance checking again. Just going to copy this one. And it's even working with my typo there. What is my balance? Checking the default balance again, and it should be getting the updated balance of 72. That is correct. Your current default balance is 72. And yeah, so okay, we have a complete working setup here right now. Now let me take a quick water break, and I'm going to check the chat, and then we're going to come back into ElizaOS specific, and how to manage it, how to control it without having to go through the user interface. One sec. It is exciting, and it never gets old when you see the agent working and taking action, making transactions live. Great. Let's take a look at the chat, what we have here. Okay, yeah, we have a very optimistic chat, right? I really encourage you to just keep doing it. If you do it a couple times, you're going to start picking up with the trend of what we're doing and what are the specific. Not to mention that you can go at any time. You can go to our Discord channel and join the community there. So we are going to be helping out. In my case, I am personally helping all the questions that arise in the hackathon channel. And yeah, don't hesitate to go to the Discord. And yeah, if you have any questions, go to the hackathon channel and you can tag me there. Okay, let's keep going with the Eliza then. Well, we're going to focus. We have the code on the Midnight MCP. Why? Because this is the code that is running and making tests to confirm that it's working code. So we have the interactions through the API defined here. Okay, so how do I start Eliza? How do I create an agent? How do I start the agent? And how do I message the agent without coming to this page here? Okay, because if we would need to do this, imagine the perfect example being the end-to-end test would not be possible if you could not access these operations without a graphic interface, right? So we have here in the Midnight MCP, we have the test directory, and inside of it we have the end-to-end test. And this is a bit more complicated because we are trying to mimic a person doing the test, right? Because this is a full end-to-end of a working agent. So this is a bit harder because we're trying, for example, our interactions here, I can simply look at the result and the end and make the interpretation. Is it working? Yes or no. Did I get a successful response? Yes or no. But in terms of the testing, we had to take the text and make like findings, like word checking and everything, right? So it's not a clean mechanic, but it does the job, right? But we are focused on the Eliza client. This is the one we're going to be taking a look at. So let me fix this and the end to end. Okay, so what we're doing here, we're creating an agent and then we're running tasks with it, right? So what we can see, for example, right here, yeah, prior to running the test, we're doing agent creation. So let's go take a look at that function. So in order to create an agent, you can make a post to the API agents path. In this base URL is basically, in my case, is localhost in port 3001. And then I'm making the call API agents, and this is a post method. And I'm sending a body of the agent data, which we can go take a look also. Agent data is this JSON that we have here. It has the character JSON inside of it. And for us to know what this is, it's coming from agent right here, this JSON file. Basically the same one we have on the base agent, aside from Discord, because this is not interacting with it via Discord, this is making direct messages. And in here we have like the server configuration for the MCP, and you can see that it's making calls to the end-to-end agent. and specific of the setup, right? So this is coming from it running on a GitHub Action server. Okay, so this endpoint allow us to create agents. We do API agents, we make a post, we include in the body the object, which is character JSON, and inside of it is a pure JSON. You can go ahead and copy the reference from the Midnight MCP. Okay, second action that we do, we can read the details. Then we read the details, what agents do we have, right? In my case, I have the ID because I got it from the agent creation. That ID is the one that I use here in order to find the details. This can be used for many things. You might have multiple agents. How do you manage them? Via the agent ID. So let's go into get agent. What is get agent doing? Get agent is making a call to the base URI API agents, but in this case it's a get, so we're simply doing it with a fetch, right? And what else do we have here? Get agent. Okay, I went through through getting all agents and not get a specific agent. So let's take a look at this specific function. Okay, get agent here with the ID. We're making a get once again, but we are adding the agent ID at the end of the API agents path, so we can get the agent. And yeah, checking the ID and the character, because it does have more information that is coming from Eliza. But in our case, we just want to check the details in the ID, of course. Okay, when you create the agent, it doesn't start, it doesn't work. It's not awake. It's in a sleep state. So then we call the start agent. You can also call this. You can call it immediately after you create the agent, or this is the same command to wake it up, even if it is like an old agent that you're making actions against. The start agent uses the ID once again, and you make a post, in this case to the API agents. You use the agent ID and the start path. This is a post, and we get a response indicating the result, right? If we were able to start it or not. We get a dot success if it worked, and if it doesn't, then we get a false response. And from there, what else can we check here? Okay, we can get the agent DM. In this case, what we are doing here in the end-to-end is similar to coming here and chatting with the agent, right? So if I do here, hello, how are you today? This is the same agent, but I'm interacting with it via Eliza chat, right? Instead of going through the Discord. This one is the same response that I will get here. Okay, so this function that I was about to present here, Eliza get DM channel, this one is going to find the channel that we are using to communicate, in this case, the channel that we have here in the URL, right? And then we can start messaging the agent once we have the information. Let's see where we are sending a message. Okay, the first one, check balance status. We're using send message. You can come here to the Eliza client and send message function. We're going to take a look in a minute. First, we have the message that we're going to send, and then we have a couple configuration stating which agent we want to communicate with. If we're going to wait for the response or not, you may not need to wait for the response. In our case, this is all testing, so all the calls here need to wait for a response. And this is the part that I said that this is a bit overwhelming, the validators, but this is not entirely. I mean, this is not this is not mandatory, right? You might want to interact with the agent and have different way to confirm that the call was made successfully. In our case, it's purely based on the response we get. So I have here a validator that takes the response and checks if it contains the wording that we want. For example, the wallet status, we are checking um, for the status, if it's ready, if it is sync. It has to include a balance, it has to include the address and many other word checking that we're doing. In case we request balance, we're checking once again numbers and the symbols that we have on the token. Let's go check how we are sending the message here. So to send message, we're using this send message function, and this is a bit over design, but as I said, this is specifically for the end-to-end test. We needed a way for it to be resilient and be able to execute the message, retry it, confirm getting a response, and confirm getting the appropriate response we want. Why? Because as you can see, when I ask for the balance, I don't get the answer immediately. I get a probably notice like, hold on, I'm going to get the balance, and I cannot accept that as a valid response. So we're doing continuous checking on the messages until we get the information that we want. Okay, so when we're going to send a message, first we get the channel ID, then we clear the history if we want to, and then we submit a message. To submit a message, we're using the URL API messaging submit, and then we're including the body, which is the channel ID, the one we found for the agent, and we have some other Eliza specific configuration. The server ID, in this case, is the world, so you can have multiple worlds or some kind of segregation of the agents inside Eliza. We're using the default one. We have the author ID. In this case, I'm using, I think, a random ID. We have the message, which is the text we want to send to the agent, and I'm simulating being in the client chat. Client chat is the simulation of being here and sending a message here. And yeah, and including the metadata, specific that this is ADM, and who I'm trying to target. Right, and from there we get a response and we go into checking the result or not. This is optional, this is not required. In case you just want to broadcast your message to the agent, that's the way to do it. And yeah, that's basically what we're doing for the agent, and this is being done via the Eliza API path. You know, we have all the server, and we can make requests to it. Also, there is an Eliza API client, which is functional, but at that point, as you need to start checking versioning, you know, and be sure that your Eliza framework is aligned with the client version that you have, right, for the npm module. So, in fact, I'm using it, but I'm mostly taking types from it, and I'm using the direct calls because we found it in our best interest to do so. But yeah, you can control the actions that we're performing here for the agent. You're simulating creating it, you're simulating starting it, and we're simulating sending messages through it and reading the responses from the API. All right, so let's take a look at the chat and see if we have questions, because we have gone through a lot. Okay, just prior to the question, I just want to once again recap that ElizaOS is making a great offer. You saw we did a Discord connection, and I only added a couple ENV to the configuration, and that was it. The plugin is already working out of the box. We just added the configuration, and it does work. Similar to the offering, we have a lot of plugins. We have plugins for Discord, Twitter, Telegram, OpenAI, using multiple providers for the AI. We have OpenAI, Anthropic, and also some other um, knowledge sources, right? You can do the knowledge plugin, which allow you to do RAG support, and yeah, there are plugins for video, audio, images, WhatsApp, scraping the browser, and many others, right? And we're building, of course, Midnight MCPs for it. So definitely we have a great offering, and we can see it working live here. So now let me check if we have questions on the chat. Okay, okay, I can see some communication going on in the chat. Great to see you guys working together, and I want to share the topic now. Now that I mean we don't have any specific questions for the workshop, and I will be checking back the chat again. But let me make the announcement that we are on we have an ongoing hackathon, right? This is building treasury management DAOs for Midnight using the Midnight NCP that we have presented here. And yeah, this is ongoing right now. We have a great prices for it. We have $1,000 for the third place, $2,000 for the second place, and $5,000 for the first place. And don't hesitate to try to team up, right? You can go to our Discord channel. You're going to get assistance there, like assistance on the setup process, and also you can go there to try to find teammates. You know, not everybody has to be technical in order to join the hackathon, because there are many parts of an application that need time and attention. One would be product ownership, being able to define um, the ideas and what product to bring to life. That's number one. Number two is to be able to do QA. You know, testing is a lot of effort, and if you have a small team, every effort counts. So you can provide probably testing assistance for your teammates. That's going to be great. They can continue to work on the solution. In the meantime, you might be testing something. So definitely go to our Discord channel and try to team up there. And even if you don't know like anyone, go there and we will try to find you someone to work with. All right then. So I don't see any specific question right now. So okay, we have one question here in the chat. A previous question: who's doing the hackathon? The hackathon is a joint effort between Dega and the Midnight team, right? So you can see all the information in our Dora Hack link. I will be getting you the links for everything right now. Allow me one sec. I will get everything posted so you can take a look. Okay, one second. I'm getting the information we need here. Okay, first let me share with you the hackathon details on Dora Hack. In case you want to take a look here, we have the gas website, and let me provide you with the Discord link so you can join and go to the hackathon channel and get assistance and get to join a team there. All right, then I think if we don't have any questions or specifics, that's going to be it for the workshop we have today. I'm very pleased to have people join the workshop, enjoy the time here, and be of assistance. Um, okay, so without further ado, thank you very much for your time, and we are a couple clicks away from communication. Join our Discord in case you need assistance. Thank you very much for your time. Have a good day.